Hey guys, welcome back to my channel. So in today's video we are diving into a fascinating security challenge that is solving a reflected XSS lab that involves escaping the Angular JS Sandbox without using strings or the eval function. If you are into the web security or want to learn some advanced exploitation techniques, stick around because this is going to be really interesting. So let's start with an overview of the lab. This challenge is to perform a score-side scripting attack on an application that uses AngularJS in an unusual way. So here is the catch, guys. The eval function isn't available and we can't use any string in AngularJS. Our goal is to execute the alert function, okay? But the catch is we can't use any of these methods. So before we jump into the exploit, let's quickly understand what a sandbox is. In the context of AngularJS, a sandbox is a security mechanism designed to restrict the execution of potentially harmful JavaScript code. So it limits the functionality available within the AngularJS expression to prevent attacks like XSS. Normally, AngularJS expression can't access the global objects like window or use the functions like eval because using this you can execute malicious JavaScript code. However, by manipulating the way the AngularJS intercept these expressions, we can bypass these restrictions. So let's see how we can do that. So let's dive into our lab now. As you can see here, we have a search box where we can inject our string. So let's inject our arbitrary string here and let's see where it is reflected in the DOM. Let's wait for the browser to get refreshed. As you can see here, we have an interesting code. Let's see what this code is doing. Angular.module lab app and empty array dot controller one control function which takes two parameters scope and parse. Scope.query is equals to empty object, var key equals to search, scope.query key index equals to test, scope.value equals to parse key, scope.query. So let's try to understand what this code is doing. So this line, Angular.module lab app, this line defines an Angular module name, lab app, and the empty array denotes that this module has no dependencies on other module. Dot controller one control function scope parse. This line defines a controller named one control for the lab app module. The control function takes two dependencies, which is the scope and the parse. Scope is an AngularJS service that refers to the application model. It acts as a glue between the controller and the view HTML. Sparse is again and also an AngularJS service used for evaluating expressions. Then this scope.query equals to an empty object. This initializes an empty object named query on the scope. So this query object is going to be used for storing this key and value pair. As you can see, here is a key and value pair that is search equals to test. So this pair is going to be stored in this query object. Then this var equals to key. So the key value has been assigned to this key variable. Then scope.query key equals to test. This assigns the value test to the property search of the query object on the scope. Okay. Then scope.value equals to parse key scope.query. So let's try to understand what this line is doing. This uses the parse service to compile the expression contained in the key variable, which is the string search. So the compiled expression is then evaluated against the scope.query object. In this case, it retrieves the value of the search property from this query object, which is test. So basically, the thing is happening that parse is compiling the key which is search, then it is evaluating it against the scope.query, so it will basically return the search term. Then the result of the search term, which is the test, has been assigned to the scope.value. So as we can see here, there is an unwanted use of this sparse. So this can be our injection point, as we cannot directly use the curly braces, but we can use this parse method to evaluate our expressions. Curly braces are used to evaluate expressions on the AngularJS, as we cannot directly use it here. So we are going to be using this parse method to evaluate expressions. So now let's try to inject another key and value pair and see what's happened. So I'm going to use ampersand to inject another key and value pair, and let's see how it goes. Let's wait for the browser to refresh. Search for the search term again. As you can see here, there is some interesting thing we got. So the thing that happened here is the JavaScript is iteratively processing each key and value pair. So this doesn't make sense at all, because this is a very roundabout way of doing things. So as you can see here, there are multiple initializations of the same variable. That is, variable key was first initialized to John Wick. After that, it's been again initialized to the term search. Same goes for the scope.query index key and this value thing. So at last, so it's searching for this s term instead of this 10 term. So this is because of the multiple initialization that happened here. So now what we can try to do is we can try to inject an expression instead of this key. So let's see, instead of this John Wick, let's try to inject a expression here in the key place, and let's see if it's been evaluated or not. So the URL encoding for the plus term is %2b. Um, if you were noticing here, before 2, a value inside the curly braces occurred here. So the masking was not done properly. For that, the value term appeared here, if you noticed. So as you can see here, the expression was evaluated, and now the search result is not being displayed against the search term, whereas it is now displayed against the key now. It is because this parse method is evaluating the expression that was passed, and it is directly then searching against it. So as we know that our expression inside the parse method is being evaluated, so now we can try to inject the alert method here directly, and let's see if it works. Now, as we can see, our alert function was inserted there in the key, but there is no pop-up reflected on the screen. So this is because the AngularJS is like JavaScript, but not totally JavaScript. So the expression inside the parse method needs to be compiled first. So here is where the sandbox comes into the play. So the sandbox blocks any malicious code during the compilation and stops it from getting executed. Okay. So here are some papers you might want to read. First is the PortSwigger page about the AngularJS Sandbox. You can take a look around here, like many things has been defined here. So the next is the XSS cheat sheet, where you can find the exploits. And you can also take a look at this paper where it shows that how the sandbox was bypassed by the ethical hackers. So we are going to use this exploits. So let's have a look at it and try to understand its working. So here is your exploit guides. Let's have a look at it and try to understand how it works. So first of all, there is a this toString method. So this is a method available on almost every JavaScript object. When called on an object, it returns a string representation of that object. Okay. For example, if there is an object called 123.toString, it will return the 123 string. All right. So toString.constructor. So the constructor property returns a reference to the function that created the instance prototype. Okay. So for a string, toString.constructor would return the string constructor function. Then you can see toString.constructor.prototype. So this accesses the prototype of the string constructor. So the prototype contains methods that all string instances inherit. Alright. So then dot char@= an empty array. So char@ is a method on the string.prototype that returns the character at a specified index in a string. Then it has been it is equals to array.join. So join is a method on the array.prototype that joins all element of an array into a string. So what this expression is doing, this expression modifies the char@ method on the string.prototype to use the array.prototype.join method instead. This means anytime the char@ method is called on a string, it will instead use the join method from the arrays. So now let's see what this part of the payload is doing. Okay, so this part of the payload uses the order by filter in the AngularJS to evaluate an expression that results in the alert1 function being called. So breaking it down, first of all, we have an array with two elements, that is 1, 2, and this part, exactly this part. So this is a filter in AngularJS that sorts an array based on a given expression. Now let's see what this part is doing. This constructs the string x equals to alert1 without using the quotes directly. So like what's basically happening here, the order by filter processes the array and evaluates the expression x equals to 1. So due to the previous modification of the char@ method, Angular JS Sandbox protection are bypassed, allowing the alert1 function to be executed. Now summarizing this whole payload, let's see what this part of the payload is doing. So this modifies the char@ method of the string.prototype, changing how strings are handled in an AngularJS expression. So next, what this part is used for? This part is used for crafting the malicious payload. This uses the order by filter to evaluate the expression x equals to alert1 without directly using string literals. So let's see how the execution of the payload has been done. So what's happening here, basically in this whole payload, the altered char@ method and the crafted payload cause the AngularJS to bypass its sandbox, resulting in the execution of the alert1. Now you might have one question in your mind, why to use this x equals to alert1? Why can't we use the alert function directly? The answer is simple: expression parsing. The way in which the expression parsing is done in AngularJS is like basically the AngularJS evaluates the expression in a controlled environment, which is called as sandbox. So directly using alert1 function within the AngularJS expression is typically blocked or restricted. So what we are doing here, we are using the variable assignment method. Using x equals to alert1 assigns the result of the alert1 to the variable x. This form of assignment can sometimes bypass sandbox restriction that looks specifically for direct function calls like alert1. So here we are destroying the behavior of the sandbox, and we are using a roundabout way to use the string to execute the alert function. So now let's watch this exploit in action. So guys, I'm going to paste the exploit right here in the URL bar. And here we have the results. And as you can see here, we have solved the lab. So by cleverly constructing the payload and modifying the behavior of the string methods, we bypass the Angular JS Sandbox and execute the arbitrary code. I hope you found this walkthrough informative and exciting. Remember, this kind of knowledge is crucial for understanding web security and protecting applications from similar vulnerabilities. So, if you enjoyed this video, please give it a thumbs up and share it with your friends. And don't forget to subscribe and for more security content. Thanks for watching, and I will see you in the next video. Stay safe and keep learning.